I said, that's a lot of talk coming from someone who's only the runner-up for the Nobel Prize. That's right, Joe. All right, I'll call you later. All right. I didn't see you there. Welcome back to another one. In prokaryotes, there are 4 different kinds of transcriptional regulation. These include negative inducible, negative repressible, positive inducible, and positive repressible, which we'll be talking about today. So describing these two separately at first, positive control is when an operon acts as an activator, binds the DNA to stimulate transcription of structural genes. And repressible control is actually when a transcription is turned off by a small molecule when it binds to the regulator protein. And putting these two together, it's exactly as it is on the board. We have an operon that's acting as an activator, but however, a small molecule is binding to this operon, and then it doesn't allow the gene to be expressed. So here's a little visual representation of positive control. It all starts off when an activator protein is created by an activator gene being transcribed, then an RNA product is translated. So we have this little activator protein, then he's gonna bind to the binding site on DNA, which then sends a signal to RNA polymerase to transcribe the structural gene, which allows the gene to be expressed. However, if we have a small molecule present, then it kind of causes a cascade of events that doesn't allow any of those things to happen. So here's the small molecule, and the small molecule is going to bind to the activator, which actually changes its shape. And because the activator has changed its shape, it's no longer able to bind to the binding site on DNA. So because we don't have that activator bound to the binding site on DNA, DNA can't send a signal to RNA polymerase to come in and transcribe the structural gene. So because of all that, because of this small molecule, which binds to the activator, which makes the activator unable to bind to the binding site, which can't send a signal to the RNA polymerase, which can't transcribe the structural gene, no more gene is expressed. An analogy I'd like to use to describe this is skateboarding in the library. I love to do sick tricks on my skateboard, but on rainy days like this, I can't do them outside, so I have to go inside to the library, which is a real shame because that's where people go for some peace and quiet so that they can get their homework done. But with me skateboarding like this in the library, they can't focus, which means they can't get their homework done. So in this analogy, the rain is the small molecule, which changes the activator, which is me skateboarding. The binding site is peace and quiet, and with no peace and quiet, people aren't able to focus, which is RNA polymerase in this analogy. And with the inability to focus, people can't get their homework done, which represents the gene product.